Coming up on this episode of the IoT Inc. Business Show.
This stream of data that's coming in, how do you process it? How do you decide what to throw away and what to keep? And it's a very different type of architecture that's required to do that properly, especially when you're talking about en masse and scaling it. The idea of data velocity and the idea of a streaming framework or stream processing go hand in hand.
On the surface, building your own IoT cloud seems pretty straightforward. But brush away some of the fluff and you'll find the non-trivial issues of data velocity, message processing, scalability, redundancy, and robustness. In this episode of the IoT Business Show, I discussed the IoT cloud with Dan Collins, its differences with the IT cloud, and the issues to consider when building, buying, or renting.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
With me today on episode 21 is Dan Collins. Dan is Chief Data Officer at ThroughTek. He got his PhD in physics from the University of Oxford and then joined the British government as its first data scientist. He's currently working on data collection and analysis for ThroughTek. Dr. Dan, welcome to the show.
Thank you, Bruce. Yeah, it's great to be here.
What, aren't you referred to as Dr. Dan over there in Taipei?
Unfortunately not. I think a lot of people tend to forget the title, which is probably fine by me.
So you work for ThroughTek. How did you end up there?
It's a little bit of a kind of a strange route to coming over. I was still working in the British government. I saw an opportunity over here. I mean, my wife is Taiwanese, so that's an important factor. I've always wanted to come and work, and I saw the job here at ThroughTek advertised, and I thought I could apply for it. My language ability isn't great, so I thought I would struggle initially, but it's a really nice company. A lot of English is spoken, which is good for me.
Now, what about your Chinese then? Are you learning? Are you learning at least to speak?
I am. I'm learning, but it's way too slow for my liking. I think everything revolves around food here. It's very, very important. So as long as you can feed yourself, that helps a lot. So
yeah, I think that's a good step one, right? Is to make sure that you can order your food and satisfy the basic needs. Then.
Yeah, I think it's food and also being able to get home and order a taxi and know where you live. These are the important things.
Yeah, when I was there, sometimes I'd be given little name cards, and then all I had to do was just sort of, push it in the taxi driver's face. Now, has Uber or anything like that kind of come on the scene in Taipei, where you just, you don't even have to worry about that. You would just type it in and then launch the app, and they would just, you don't have to speak or even exchange money at that point.
Yes, not Uber specifically, but there are local versions that do the same idea, where you have an app, you can order a taxi to the door. I've not actually used them myself, and mainly because I don't tend to use many taxis. The public transport is very, very good here with the MRT, which is kind of like the underground in the UK. So
yeah, the underground's good, and also the bus system, or I think it's trolley too, right? Or I can't remember which one, but that was like really cheap and really efficient as well.
Yeah, it's great, and they all use the kind of Easy card, which again to draw a parallel with London, is a bit like the Oyster. So you can just swipe in for the MRT or buses, jump on, and again all the signs are in English on the buses, which really helps.
Right.
They're a lot more complicated, but.
Well, tell us a little bit about yourself and specifically your background in IoT.
Sure. Well, I think the bio you read out kind of covers most of the important stuff. I've not been in the IoT area for too long, but I have kind of spent the last, I guess, 13 or so years working in the admittedly broad area of data analysis and distributed systems with my studies. So I completed the PhD in 2010 and worked as a postdoc for a couple of years after that. And I kind of started to realize that the work I enjoyed the most revolved around the computation analysis, the modeling side. And kind of from that decided to have a little bit of a change of career. And that's when I applied to the British government and became a data scientist.
Now, what was it before? I mean, you're saying as a postdoc you were doing what was different than being a data scientist?
Well, it was a little strange. So my PhD was in semiconductor physics. So it was kind of applied, mostly applied to down in the lab, experimental work, but also with computational modeling, but a very specific type of modeling, not stuff I've had to do since. And then the postdoc shifted slightly again into neuroscience and biophysics work, and that's where I
that's a shift.
Yeah, it was a bit of a change. So, and that's why I spent some time in Japan learning how to do cell culture and spectroscopy and optical work there. So, a little bit of a change, and then I think that kind of helped focus my attention. Realize that what do I really enjoy? What do I want to do long term? And hence the data science route, which is really not obviously a new career, I suppose, a new field, relatively new,
for sure,
but matched everything I wanted.
Yeah, and I guess that was kind of, to a certain extent, a common denominator as well. You're using data science, or I guess applied data science, in each of the two different areas then. Yeah,
and I think it comes down to data science is such a wide scope. It can be applied to anything in any field. Like I said, whether you're in government and the public sector or private sector for driving business. But also, coding is at the heart of it, and algorithm development and usage. And I think because that's the bit that I could quite easily stay up for hours doing, rather than going down to the lab, it kind of made sense to do what you love, and I've never regretted it, really.
Yeah, well, now you're doing what you love in a very cool city. Well, you've given us a couple interesting factoids, but what's something else that most people don't know about you?
One thing, I suppose, is I'm a very keen hiker, and a few years ago, and over the past few years, I've done quite a few long-distance walks. So I've done a few in the UK and a couple around Europe. One in particular was across the island of Corsica. So it goes across the whole length over the watershed, the mountain range. It's a very challenging one. It's called the GR20. But it was absolutely wonderful. I did it by myself, and I'd love to revisit it. It's an absolutely amazing place.
Now, are there hiking opportunities in Taiwan?
There are some. One of the attractions, I think, of Taipei and Taiwan is that the fact you've got mountains and you've got the sea right next to it as well.
Yeah.
The trouble is with the mountains, sometimes it's very different style. There's so dense vegetation, with it being a tropical, subtropical island. So it's quite hard to hack your way through some areas. But there are lots of trails around, so it is great. I mean, as long as the weather's reasonable and not too humid, you can escape and go to some wonderful places.
So at least that means you can hike, about 2 or 3 weeks a year?
I suppose actually, with them being mountains, that's the one way to escape the humidity. True. They certainly go extremely high.
Is that right?
Around 4,000 meters or so, which is quite large, especially for a small island like this.
Yeah. It's funny because I think I only visited one other city and I've probably been to Taipei. To Taiwan, but specifically to Taipei, maybe 10, 15 times. But I never seemed to get out of the city except for that one time. And I heard the south is really nice, and there's lots of really nice places to visit.
Yes, especially if you like seafood as well.
There it is, food again, right?
It always comes back to seafood, but also a nice sandy beaches right in the south. So something for everyone.
Too. Yeah. Well, your background's in data science, but today we're going to talk about IoT clouds, specifically the differences between IoT clouds and IT clouds. So why don't we start there? Why don't you describe, first of all, what is an IoT cloud service, and what are the big differences between it and a regular IT cloud service?
Right, yeah. So I think the two, I think in many ways, the fundamentals are the same. The idea of an IT cloud, I guess a lot of people are familiar with this idea of having virtualized instances and computational power that is kept separate from the business. So you're not having to have the initial outlay of the bare metal servers and the depreciation costs and maintenance. So really kind of abstracting it and having the computational power there on demand, which is very important. Right. I think the way in which the two are essentially the same is that The differences come down to really the application. So the IoT cloud or IT cloud service, the idea really is that you utilize this flexibility and the economic benefits of cloud providers. And then the difference comes in what you're doing, what type of devices you're connecting to, or what problems the service is trying to address. Mm-hmm. So I don't think there's a need necessarily to call it IoT cloud and IT cloud. I think a more traditional IT cloud service would typically deal with, the fundamental business services. So that's customer relationship management, or even human resources portal management, asset tracking, or point of sale services, these types of things for a lot of businesses. And these systems themselves will probably rarely be in the cloud. So it's often your main data center will be there, but you're connecting to these data sources and having to process the data and analyze it.
So isn't one of the big differences between an IT cloud service and an IoT cloud service how you get the data in and out? So the APIs, the protocols, SDKs, and so forth?
Yeah, that's true. I think from a traditional IT cloud service, some of that will be based on more traditional M2M technology. So there will be a certain amount of overlap. But certainly in the IoT cloud, there are other algorithms, other protocols that are being developed, and we do have to support these. And I think with the wide variation of what's out there at the moment, an IoT cloud has to be inherently flexible at this point, certainly until we get more standards developed and more kind of clear winners in this area. So certainly things like MQTT as a protocol is very, very popular for pushing and publishing data. It's a publisher-subscriber model. It's one that most people try and support.
Now, what about from an API point of view, or say an SDK point of view? Is that something that's being standardized as well, or is that just sort of just depends on your environment?
I think it does. It does normally depend on your environment. I mean, I think the idea of APIs are relatively standardized, and the way that if you have a cloud service, the main challenge, as we were just saying, is collecting the data and pushing it into the cloud. Beyond that, APIs are typically used by developers or other people who want to connect to the data that you've collected. So the development of APIs at that point is normally relatively straightforward. And SDKs, of course, certainly come to play in particular when we're dealing at the device level. If you want to install proprietary or customized SDKs on the chip, almost on the firmware sort of level, and you implement it there, that's very important for a lot of companies to enable the connection protocols to happen. So.
Yeah. Now, would that be in the second architecture where you're saying there's a direct device to cloud connection?
Yes. Yeah. Definitely. That's a typical one. It's something we utilize as well. We're having SDKs on IP cameras, for example, to enable the P2P transmission of data. So that's very important. But you can also use that to, for example, use this SDK to set up things like message brokers on devices. So again, coming back to that idea of a hub or gateway model, you may want your set-top box to act as a broker, and therefore it will have that broker running in the background to enable it to act that way. And it's a relatively low footprint, so it doesn't take up too many resources on the gateway itself.
Okay, well, let's take it back. So our listeners are listening, and they're saying, okay, well, how do I, what's important? What should I be looking out for? So the first thing is obviously that it needs to support the protocols that you're using, so you can get the data in and out. What are some other differences then?
For the cloud itself, I mean, I think both. I think if we look at the parallels, actually, there are a lot more parallels because they both, in theory, need to be able to handle high velocity data streams. I think it's more the case in the IoT cloud. This is very, very specific. What we want to do is have millions of these devices around. We want to be able to take that data in and do something useful with them. And that involves developing a very kind of robust stream processing framework. I think you could argue the same for a typical IT cloud service, but I don't think they've been developed normally in that way with the streaming idea at its heart. But they could be. They could be consolidated into one platform which can handle high-velocity streams from IoT devices, but also typical business infrastructure. And this would all kind of center on this idea of message queues, using something like Kafka to consolidate data streams from devices, but also from your point of sale service or customer relationship management or databases. So this idea of having a data backbone is very, very important for any infrastructure. But I think there are a lot of parallels there.
Now, is that part of the cloud infrastructure then, this data backbone, or would that be living somewhere else?
No, it would definitely be part of the cloud. Things like these distributed messaging queues. I've mentioned Kafka a lot. I realize people may or may not have heard of it. It was developed by LinkedIn originally, and clearly they had very specific user needs in terms of that their website was growing extremely quickly, and they wanted to log changes to the website, to messages sent, all this type of work. One way of doing that is to have a message queue which basically logs changes and keeps the time order correct, very importantly. So in theory, you could regenerate all of the time events that happened over the past maybe day or 6 months or however long you specify you want to store the data for. So having this central message queue in the cloud just means that all of the data will be pushed to it, and you have a very, very concrete way of telling what data went in which position at what time. And you can set this up and you can scale it massively to have millions of messages per second being pushed to it, and then get taken from the message queue into, for example, a web front end or a database or other systems. So it acts as a backbone and a funnel through which all of your data should go through.
Yeah, and I guess there's a bit of a blurring because, when I hear you describe the messaging, the message center, so to speak, I'm thinking IoT platform, and the cloud is part of the IoT platform. Yeah, maybe you can kind of expand on that a little bit. Is that something that you would get if you were to sign up, for example, with Amazon's new, IoT service or Azure? Are you going to be getting this as part of that, or is it more part of a platform like yours, for example, that you guys offer, that ThroughTek offers? That's part of the the software of the platform, or is it just blurred and they're kind of the same anyway?
I see. Yeah, I mean, my opinion would be, and certainly from ThroughTek's position, is that that's something that we offer. That is a function. Most people who use it do not need to know that it's a stream processing framework and it's built of these several parts in the cloud. What they need to know is they can connect devices to it, and we can generate graphs, insights, the analytics side. So the actual means to an end, I think in terms of architecture, that is something that should be implemented by these platforms themselves. Otherwise, they can't physically handle the data streams coming through.
Right. So I think what you're saying is either you're going to develop that yourself and the cloud needs to support it in some way, and I guess that's not going to be much more than these APIs we were talking about, or you're using a platform. But it just has to be supported by the cloud. It's not something that's necessarily or that is offered by the cloud services.
Yeah,
am I right?
So in theory, you could go to the cloud and you could get all of the parts. A lot of it would be open source, that you can develop your own stream processing framework. I mean, that's the beauty of the cloud. I mean, you could just get the computational power. Realistically, there are a lot more challenges involved, and this is where, for a business, you have to make the decision whether you have the in-house capability to assign several developers and data engineers to build this up using cloud resource, or you go through a platform who have already done this in the cloud and just bundle it with the platform as a functionality. So it's not you don't have to know that it's a stream processor. You just know that you get the results from the platform itself.
Yeah, I mean, and that's probably actually a good place to back up a little bit is the difference is if someone can approach building their IoT product, let's say we're building a product, they can approach it in a number of different ways. One would be to assemble all the parts themselves, and one of those parts would be the cloud, and then another part would be the messaging, the messaging system that we were just talking about. So when you're selecting the cloud for those purposes, it may just be, if you're rolling most of that yourself, it may just be you need to have the right APIs that fit with your development environment. But the other way to do it is obviously, our last 3 episodes, and we've talked about platforms quite a bit, is to choose your platform. And is your experience then the platform always has the cloud associated with it, or are there choices? I guess where I'm going from is if someone's thinking, okay, I'm building my IoT product, one way I can do is build it myself, obviously, and other ways I can build a platform. For the cloud, is the cloud taken care of completely for you if you choose a platform, or are there still considerations that you need to take into account?
Normally, and certainly in my experience, if you choose a platform, the platform itself will be built on the cloud. But again, the customer doesn't necessarily know about that, or doesn't necessarily have any specific preference with regards to...
Right, so there's no choices they need to make. I mean, if they choose the platform, they're choosing the platform, and the cloud decision is made completely for them.
Normally, I think as a business, and certainly coming from my personal experience, as a company, we use a lot of AWS and also data centers in China, so Aliyun or Ali Cloud. So what we'll do, we'll build on that to build the best product, really, the product that allows lower latency in terms of getting your data and receiving it. We feel that choices over cloud are probably, if people have very specific reasons for choosing it, we can accommodate that. But a lot of our stack will be built on certain cloud providers. We could change if we needed to, but really it's just about driving functionality. So I would say that with these types of things, it's not massively important, and the platforms are normally built on a cloud based on maybe their developers who are familiar with the APIs for certain cloud providers, or just through good experience or support levels, this type of thing. But I think as a business, when you choose to work with a platform provider, a platform as a service, very rarely do you actually get to the point where you want to talk about the cloud provider specifically.
Right. Yeah. Okay. Well, then that's a good, we should have clarified that right from the very beginning. And so when we dig into the cloud today, it's either because you're going to build your own cloud solution, or it's just for informational purposes for when you discuss your platform, just to know how it works, and maybe it's going to uncover some other issues. All right. So getting data in, we've covered. It needs to support the different protocols. What about getting data out? And let's go to your area of expertise, specifically big data, analytics, databases. What do we need to be concerned about there?
Well, I think it's a very general sort of statement. We have to be concerned about doing the right thing with the data. I think a lot of people get bogged down with the infrastructure and collecting this stuff. Maybe this is obvious, but very few people are really thinking properly about what can we do with it, how can we analyze it to bring value. And that's something I'm particularly interested in. I think areas such as I mentioned before, like the smart home, I think we're still in the phase now, which is a convenience phase. A lot of the opportunities it provides are time saving, but I think the way it will really sort of pick up massively is when we can appeal to other areas, and that those sort of things are kind of improved health and security, but mainly this idea of affecting the pocket, really. So cost saving. I haven't seen too many really good examples of using smart home data to actually save a lot of money for people, and to provide recommendations on clever energy management, for example. And these are all possible. So I think as a general statement, that's the one thing we should be careful about. Let's think about what we're doing with the data rather than just let's collect it because we should and we'll find something to do with it. I think from a technology point of view that there is a lot to think about from a logistics point of view. So you have a stream processor. What do you use to analyze that? Do you go with Hadoop or a Spark stack? But again, these are technical issues that I think if you're in the position to buy this technology, you should be familiar with, but you need to really engage quite early on with cloud platform as a service providers if you go down that route, to discuss the needs.
Yeah, no, absolutely. What I recommend to everybody before they approach, even getting to this stage, is to do two things. The first thing is to build your IoT business plan, and the second thing is to build your business information requirement doc. Yeah. And the business information requirement doc is kind of like you were alluding, is really strategically think about all the information that you need. What is the information that you need? From there, you're going to figure out the data that you need to basically build that information. You're going to figure out the types of analytics that you're going to need to produce that information, and then everything else falls out from there. It falls out in terms of the databases you need to support those analytics. It falls out to the cloud type services that you need to support that information, right? I mean, I think that's in essence what you're saying.
Yeah, and I think you've kind of hit the nail on the head there. Something that I always like to say is that the cloud doesn't magically address all business problems just because it's a cloud and you can start pushing data to it. And I think that is obvious, but I think it's worth emphasizing, like you said. But with most things, I think start with a thorough critique of the state of the business. I mean, look at areas that need improving. This could be things related to inefficiencies in data processing, or things like data center locality issues, or so that could represent a bottleneck. Infrastructure, spend on infrastructure maintenance, this inevitable depreciation. So kind of look at these, but then more importantly, perform sort of what you'd call like a data audit. And this should look to highlight a few things. You could look at what data you're currently collecting, what are you collecting but not using, how do you currently collect the data? So what formats do you get it from, like JSON, CSV, PDF sometimes, Avro, Thrift? What additional data sources do you see coming in that could be completely new? Right. And can you estimate the velocity, the speed at which that's coming in? So does it need a stream processor? Does it need batch processing? Do you have special security requirements? So all of these sort of things need to, in a logical step, should be happening very early on, pretty much before you engage properly with a cloud provider or a platform as a service or start going down that route. I think that's always a useful thing to do.
Yeah, no, I think we're violently agreeing with each other. Yeah. But I want to pick up on something. I want to pull on something. You've mentioned velocity, data velocity, a number of times. Why don't you expand on that a little bit? Because I think I'm getting the gist. The gist is being you may be able to do things in real time. You may not be able to do things in real time. But you have brought it up a number of times. So why don't you expand a little bit on that, Dan, and tell us what you think.
Sure. Yeah, I'm aware I've used that a few times. I think it comes from one of the definitions that people have for big data. The velocity, the variety, veracity. Okay. So I was using it in that context, and for this, it's particularly relevant for IoT and sensor devices because they will be publishing data typically, anything from every second or every 10 seconds down to milliseconds in theory. So, so purely from a velocity point of view, it's this stream of data that's coming in. How do you process it? How do you decide what to throw away and what to keep? And it's a very different type of architecture that's required to do that properly, especially when you're talking about en masse and scaling it. So this is why the idea of data velocity and the idea of a streaming framework or stream processing go hand in hand. You have a stream of data coming in, you have a message queue and analysis software, so things like Spark to analyze this stream in real time, and maybe do things like aggregation in real time, so you don't have to keep every value, just aggregate them and calculate averages, very simple. And by doing that, you almost provide a real-time filter, and those values then can get put to a database, which then drives the front end and allows you to generate graphs very quickly. And it means you're not collecting all of the rubbish and just letting it pile up. So it's the idea of having a bit of logic, a bit of intelligence in your data stream.
Okay. And I guess I'm assuming in most IoT products, and we'll just use product, for the purpose of our discussion, but you're going to do some things in real time, and you're going to need to basically work on data at rest other times, more in a batch environment. What should our listeners be looking out for? I mean, you mentioned Spark, as something that you may want to use for the real time parsing of the data. But I guess what are the conditions? What are the considerations to think about for the cloud and let's say for the platform when you're considering the different types of, I guess, data velocity?
Well, I think. So firstly, you're right. I mean, the idea of streaming and batch processing, that they do go hand. You have to have both functionalities. Yeah. And right. The reason I've mentioned something like Spark is, firstly, because of its popularity, and it's popular for a good reason, but also because it provides both of those functions. So it allows you to stream data, but also in theory, once you have a day's worth of data you've aggregated and you want to perhaps do some machine learning algorithms on that, you can use it in batch mode to do this. So it combines the best of both worlds. So you can have a single framework that's open source and use that to address both business needs. So I think you do have to consider that. The main thing, again, from a business point of view, you should be thinking really about what are the insights, what do you care about, what are the questions you need answering. From buying this sort of software and embracing a solution, I think Spark and this framework has kind of come as a clear leader at the moment, but I think there are other similar ones that offer similar functionality, like using Kafka and Storm, for example, which are developed at Twitter. So there are a couple of similar rivaling ones, but I think in terms of what people have to think about, it's really about what is the end result. From a technical perspective, you can achieve that in different ways and different stacks, if you want.
Right, with different stacks. Well, let's take it back to the technical considerations. Will any cloud be able to connect up with any of these different analytics programs and the databases they support, or are there limitations?
Yes, certainly. I think any cloud can certainly connect to them. I think we have to be careful again when talking about the cloud. If we if we think of the cloud in its basic form, it's really a massive data center, and you can virtualize and create virtual machines and create clusters and any framework you want. Most of them will, if you look at a cloud like Amazon or Google, for example, or Azure, they will give you a bare Linux machine. And if you have developers, you can build up whatever you want. If you have people who are offering a service, this is what you build on. So in theory, any cloud provider, because they start at the same building block with a very bare Linux operating system, all of these will be naturally supported. So again, it comes down to maybe considerations and subtleties to do with data transfer is a very important one. If you have located data centers across the world globally, which you should have for redundancy reasons, then perhaps as a business, if you're porting and transferring a lot of data between them, you want to have a plan, a tariff that doesn't charge as much for data transfer. And people can be quite creative with that. Certainly as a company, if you're dealing with platform as a service, you might be creative of where you put data centers just because they're cheaper to use or the data transfer costs are less.
Well, can you? Yeah, I mean, I think that's definitely an important topic. Can you expand a little bit on, I guess, maybe the business models, that you can come across with the cloud services or with the platform services specifically? I guess it's the storage and the computation, and I don't know if there's anything else that they charge for. But what is it from a cost point of view? What should we be looking out for, and computing, storage, communications, maybe just go through that with us a bit.
Yeah, they're all very important. So yeah, a lot of the providers now are pretty similar, and perhaps not surprising if you're looking at just the bare costs of using their cloud in terms of data transfer, in terms of storage and actual computational power for these virtual machines that you get. I mean, if any of the listeners have kind of gone on to things like Amazon Web Services, and you can select whatever level of machine you want, from memory levels to processing power, etc., and storage. So these are all configurable options. If you're developing something like this yourself, of course, coming from the point of view where a business, you may want to embrace and engage with a provider. Now, in those cases, you will say, this is what I want to achieve. The provider will go away and build this solution, but of course use a cost-effective way of doing it, to use a certain cloud provider, whichever's best, to offer a lower price point. So I think it really depends on which point that people are coming from a business. If you're trying to develop this in-house, then of course you do need to go down into the nitty-gritty of each cloud provider and calculate what's important. But if you go with a platform as a service, this will all be taken care of, and that's kind of more abstracting the idea down to business values and what questions do you want answering.
And so what you're saying is, if you do go with a platform, then they'll figure out the platform provider, the service provider will figure out how to get the appropriate analytics, into the network fabric, how to get the appropriate databases to support that into the fabric. But if not, then you're kind of doing it yourself, though.
Exactly. Yeah. I mean, and I guess that is the point of something like a platform as a service. It's meant. Lots of companies are doing it. As a company, we like to do sort of an end-to-end idea where we start with consulting with people like, what do they want to achieve, what devices do they have, and what do they want at the end, and we'll do everything down through to the analytics and giving them dashboards and visualizations. Other companies will go down kind of a similar modular route. So you can come in as a company and say, okay, I just want storage capability and I want user registration and device registration. We do the same, but other companies do it. IBM Bluemix, for example. Then you can just pick and choose. But what they typically won't do is kind of the end-to-end customization. You will have to have someone, normally software developers, who are trained enough to say, right, I want to use this. I'm going to use this module and look at the database, play around with it and pipe it and connect it to other data sources. So the core functionality is there, but the actual stitching together of these services is slightly more tricky. And it's certainly doable if you ever have an in-house team, but it's certainly not a sort of, here's the finished product and let's iterate on it.
Yeah, and that obviously keeps system integrators in business as well.
Yeah, exactly. Yeah.
Right. Yeah, no, I think the point is very clear. In previous episodes, it's been clear as well that there's very few situations. Well, let me ask you, I mean, when would be a situation that it would be best for a customer to, in fact, not rely on a platform and rather build everything themselves, including the cloud infrastructure that we've been speaking about today?
I think the most obvious case there would be if they have a very particular or bespoke need that isn't addressed by the. I think as a company that offers a platform as a service, some of the architecture will be relatively fixed, and of course the turnaround time to changing anything like that and making it truly bespoke in terms of very specific requirements is quite difficult. So if they do have a particular need, or sometimes if they have a team that have experience in the area and want to build it up themselves, I think having that knowledge and being able to actually touch the system and have the working knowledge of it is very useful to have. And it does mean little tweaks can be made and you can start changing it and be a more agile business. So I think that it's definitely a viable solution, but it's a tricky one, and it's something that a lot of people don't understand the complexity of running a truly distributed and reliable system for this type of data analysis. It's very easy to do a proof of concept system with a very small cluster of machines that can take a small amount of data. Making this truly scalable and robust and resilient to failure, which these things always fail at some point, it is the hard part. So I think it's this sort of cost and benefit analysis there, that what happens if it goes wrong, and do you want to sort of SLA the service level agreements and type in contracts? But people can definitely go off and do it themselves and start picking and choosing things from cloud providers and building it up.
Well, why don't you, you have obviously some experience in this, and let's talk points of failure. Let's talk about these gotchas that people may run into. What are the more common, issues that people don't consider? Like you said, building a prototype is relatively simple, but when you start going to scale, what are some hot areas that people should be thinking about?
I think just with the area of creating distributed systems. So the first one, the basic one, this idea of a cluster of machines to do whether that's a cluster for the message broker, this Kafka that I mentioned, or maybe it's a cluster for Spark or Hadoop. Now, if you make a very small, you could have a single machine running Hadoop or Spark, and you could do that on your laptop. And but you could, if you start scaling, let's say you've got 3 machines, that's fine as well, and you can keep track of those. If you have 100 or 1,000 nodes in this sort of in this architecture, you have to start then being a little bit more intelligent about how you're monitoring these. How do you automate things like cleanup of the memory, of the space that it's using? How do you dictate that? How do you link it in with versioning tools such as GitHub and Subversion? So when you make changes, how do you roll it out and test? So you have to start building functional tests into your framework, and every level adds extra complexity, but also, of course, adds another element that can fail in it. So I think that's from the very starting point how it gets difficult. I think from a distributed point of view, again, is this idea of having multiple data centers. I think in theory it's not too bad with cloud providers, because you can suddenly spin up an instance of a machine in the east coast of America, or you could have one in Singapore at the same time. And that can be done in 30 seconds. So easy to do that. But of course, the connection between the two and how you make the data availability between the two, how you mirror data between them, if you want to have backups and this sort of thing, is quite a tricky one to get right. And that's where the data transfer comes in. If you don't want to have mission critical data that's just in a single data center. That's probably obvious to a lot of business listeners. But if a data center then fails, what do you do? And how do you mitigate that? So that's the idea of replicating data across the globe. But it's tricky. It's tricky to get right and tricky to get in a performant way.
Yeah, I say start small, but think big. And I guess you're thinking big there, because you're thinking global, you're thinking, international. And I suppose it depends on the application or the product or the environment or the system, IoT for all of them. But yeah, if something is going to grow at some point, even if it is a very simple product, if you're going to start selling it worldwide, you are going to have these issues. And that's one of the big differences between a connected product, or an IoT product, I should say, and a regular product, is because you always have this connectivity to, quote unquote, the cloud. And all these issues that you basically went through will be important.
Yeah, and I think that location, just as an example, well, as a company, we started as a IP cam manufacturer, and a lot of devices we support are cameras, so we're quite good at video streaming and some of the analytics. But because we have close connections to manufacturers, we have maybe 6 million devices across the world that have our solution on, but they're spread across 160 countries. So it is something, because if you work at the base and work with manufacturers, a lot of them are made in China or Taiwan. very quickly they get distributed. And then what do you do with that? Because we're still having to support them as soon as they leave the central base and go out. So very quickly that becomes a distributed problem.
Yeah, no, that's true. And I mean, you're not going to be able to do that if you're U.S. based. You're not going to be able to support, the Taiwanese cameras, specifically cameras, I should say, in a very cost-effective way if you're streaming halfway around the world, literally.
Yeah.
No, that's a good point. Well, all right. So that's excellent advice. Maybe I like to move into best practices now. Which I guess we've been talking about them to a certain extent up to this point in time. But what are some best practices that you've seen for implementing, I'll say the IoT product cloud, but we know kind of now in the context, whether that's a standalone or as part of a platform. But what are some best practices? Scaling, issues with distribution is a big one. Scale, clustering. What are some other best practices that you can share with us?
I think that this sort of question could be answered in two ways. So I guess it depends if you want from the point of a business buying, someone in the business who's buying the solution.
Let's start there.
Yeah, I think if you're in that sort of role, I think some of the best practices that we've mentioned, I want to re-stress is this sort of assessing current in-house expertise.
Yes.
Excuse me, and that's very important. So you have to be very honest about that and what you can afford to do and what you currently have, and then be open to engaging with companies of all sizes. And that's kind of after or during that data audit I mentioned previously. So I think that's really, really important in this sort of area. And I think what I should also mention is this: for a lot of people, their first port of call might be dictated by legacy systems that they have. I saw, I've seen this when I was working in the government. I've seen in other areas that legacy systems are inherent across many areas, and people may want to go straight to IBM if they have a lot of that. And I'm not saying that's a bad idea, but I think people have to be open-minded about sometimes you can get more compelling solutions from other providers, maybe other large providers, maybe other small ones. So especially ones who are more IoT focused. And that's particularly relevant if people are looking to branch out or change their core business model into something different, or maybe start providing support for IoT devices.
Right.
So that's very important. And then either way, I mean, engaging early on is the important one as well. You can't ramp this up very, very quickly and suddenly have something, especially if you want to start doing more in-house. It's very much sort of a long-term investment of kind of building this up and testing scalability and distribution, going with reliable cloud providers. So if you want to do it yourself, don't go necessarily with some very, very cheap provider that seems to be offering bare metal servers in a random location. Go with some of the big ones. They offer very good packages, I think. I think as a data scientist before and a developer and doing things like this, I love them. I think they're brilliant. The ability to ramp up a machine, test things out, and then destroy them, and only costing maybe $1 or $2 is a great, great thing. And I think it's really spurred on a lot of innovation, especially in this space. I think as smaller companies, I think the only way smaller companies can do well in this area is the ability to find a niche, but also do things very, very well, and have the ability to not have the requirement to shell out lots of money on infrastructure. So this is more of a testament towards the cloud, but it's a very important one for us. You don't have to go and buy the bare metal servers and have a data center and pay for all of the cost and the cooling. So really embrace the cloud, go with trusted providers. Have people in-house that know what they're doing and have experience. Don't just assume that internal developers can just say, oh, you can make a cloud platform and allow us to do IoT streaming, because it's not a very specific subset of skills in building these systems. So respect data engineers and people that are working these before, and certainly bring them into the company if you want to do it in-house.
No, I think a key word is honest, an honest audit of your internal capabilities. And sometimes, your developers, they may think they can, but you have to be really honest because, like you said, it is a different beast to a certain extent.
Yeah.
Okay, so that's looking at it from, you said there's two ways to answer this question. That's looking at it from a business point of view. What about looking at it from a technical point of view? What are some best practices?
So I'm a big supporter of open source tools and code. I think it's a wonderful thing, and there's a lot of extremely good software out there. I mean, we've already mentioned a few, but things like Kafka, it's open source. Anyone can set it up if you have the skill and you want to go through the chores. You can do that. Spark is open source. You can use this. So in theory, a lot of these components, best practices really involve going with the best products that tend to be in the open source area, I would always discourage people from going down the proprietary route too soon for the sake of proprietary routes. There are often sometimes requirements people may have about security concerns, and that there'll always be edge cases. But I think generally, look at what's out there, don't reinvent the wheel. Start using those and become familiar with them. As a developer, you want to build a stack that's been tested already. And this is where I think it's important. It's hard to be too novel or too inventive when it comes to building this type of functionality. I see it more as an engineering problem and a fascinating one. But again, don't become separate from the end result of why you're streaming this data through. You've cleaned the data. You've checked its validity. It hasn't changed along route. You've defined schemas, which is very important. But at the end of the day, you're getting this data at the other end of the pipe. What are you doing with that to add value? So always have someone at least in the group or whose sole focus is to start working on that and start to say, if I've got data like this that I know we're collecting, these are the cool things I can do with it, and this is how it's going to add value to the business. So that's what in my team, that's certainly something that we've got a few people, including myself, of course, thinking about all the time.
Yeah, no, and as we said, I think that's something you need to think about up front. And I would concur with you. I mean, if you want to start being creative, we're not talking about creative stuff here. Like, let's face it, this is stuff that has been done before. To a certain extent, it's plumbing.
Yep.
Where you want to be creative is in data modeling. Where you want to be creative is on the application that's going to be controlling your model. Where you want to be creative is how you use your analytics. There's where the creativity should be.
Exactly.
And that's where really the intellectual property will be also for a company. And that is where they need to understand it and differentiate themselves. Let's face it, you're not going to differentiate yourself with a better cloud. You're going to differentiate yourself with a better model.
Exactly. And it's a lot, if you have a great idea about what to do with that data, it's a lot easier to make that a reality than to find some really niche area of developing some additions to Kafka that's going to help a certain niche use case. I think just focusing on what you can. I mean, that's a very tricky thing to do. And a lot of very talented people have been developing Kafka and continue to do that. I think,
no need to redo that.
So yeah, I think sometimes step back and just think a little bit more about the fact you mentioned data modeling. I love because it's so important. I think it's undervalued. And I think a lot of problems that people have in scaling can be addressed by data modeling, but also embracing schemas. I think in terms of this sort of area, a lot of people, NoSQL databases, I don't want to go too specific, but became very, very popular with MongoDB and other solutions. And a lot of times that's used by people just to store data. They have data coming in, they'll just dump it into a NoSQL because they don't have time to think about maybe a schema, or they just want to store it for now. And that's great in the short term. But I think if you start embracing proper data modeling and think about, what queries will I make on this data? What will I be doing? It not only helps you create a much more performant and scalable system, but it also helps you define the business problem and the solutions you'll be developing. So it's really that the schema design, data modeling, it's something I care a lot about.
No, and I do too. And we're going to be spending a lot of time because I don't think it's just valuable. I think it may be the most valuable part of an IoT, an IoT solution. Yeah. All right. Well, Dan, this has been very informative. How can people find out more about you, or specifically ThroughTek? Where should they go? And do you have anything specific going on right now?
Sure. Well, firstly, if you want to find out about ThroughTek, we of course have a website. Of course. The address is www.tutek.com. Or ThroughTek, You can just Google that, and we have a white paper on there, so that's no problem. And also we have accounts on Twitter, Facebook, and LinkedIn. So again, if you just use ThroughTek and any of those accounts, you can get straight through to it. And a YouTube channel. So I did a few talks recently, one in London at the M2M World Congress, and also in San Francisco, the IoT World. So you're very welcome to go on there and check out our YouTube channel.
Oh, excellent! So you had them recorded then.
Yes, the London one was recorded. The second one, professionally recorded. The second one was, I would say, less professionally recorded. But so perhaps I encourage people to look at the London one in particular. I think the content is mostly the same for those two talks.
All right. Well, we'll put all this information in the show analysis notes so people don't have to do too much searching. But great. Well, thank you very much. I appreciate your time, and we'll be talking soon.
That's great. Thanks, Bruce. I really enjoyed it.
Okay, that was a good talk with Dan Collins of ThroughTek. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is To Be or Not to Be a Data Hoarder with Steve Stover of Prediction Software. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a fair-weathered one.
You have been listening to the IoT Inc. Business Show.